Welcome to our tutorial. Now we are moving to the part 2 question number 8. So I hope first part may be helpful for your preparation. So now we are moving to the part 2 question number 8. So first I want to read the question. Two free point charges, the given one is plus 4e, another one plus e, are placed at distance a. That means they have one 4e, then another one we have plus e. They kept at a distance is nothing but a. So where third point charges, we have another charge, third point charge q, should is placed between them such that entire system may be in equilibrium. This is the main important one. So entire system they may be equilibrium. So both are positive when you are placing between any point. If it is q, we already know that previous sum we discussed what is the net sign of this. What would be the magnitude and sign of q? What type of equilibrium will it be? So the question is we have to calculate magnitude of q and sign of q. So already we know that based on the previous one, solution is nothing but sign of q is negative. The reason, this is also positive, this is also positive. If you want to make it in equilibrium, so q must be negative. So now we need to calculate that magnitude. So then we will calculate at what point it will get 0. Clear? So based on that only we are going to take. So first we are going to take equilibrium condition. Okay. So we are going to take, this is positive, this is negative. So we are going to take attractive force. Attractive force between plus 4e and q is equal to attractive force between q and plus e. We need to equal that. Based on that we have to work. We know that the force is nothing but k q1 q2 divided by r square. We have to substitute k, q1 is nothing but plus 4e and q2 is nothing but q divided by, we will take a distance of x, this will be a minus x, we have to take here, so x square is equal to k plus e divided by a minus x whole square. So this is the one we have to focus. So now we have to cancel each other. So now we need to cancel each other. So k will cancel, e will cancel, q will cancel. So finally we have 4 by x square is equal to 1 by a minus x whole square. So cross multiplication. So 4 into a minus x whole square is equal to x square. So based on this, we need to short out. For that, I'm going to take square root. So based on this, we can calculate the x. So 2a minus x is equal to x. So 2a minus 2x is equal to x. 2a is equal to x plus 2x. We are taking here. So a is nothing but 3 by 2x. Sorry, we need to calculate x. So 2a is equal to 3x. Based on this, x is nothing but 2 by 3a. So we need to place here negative q should be at 2 by 3 of a from plus 4e. When you place a distance of 2a by 3, the system will be equilibrium. So now we need to calculate that magnitude of q. So how will you do this? Any idea? For that we have one condition. For a system of charges is in equilibrium, so that net force on each individual charge must be 0. The condition is for a system of charges to be in equilibrium, the net force on the each individual charges must be 0. For this condition, we need to calculate the magnitude. So based on that, we can take any charge. Okay. So first, we need to take plus 4E and E. Based on that, we need to calculate the force. Similarly, we are going to calculate any one charges. So 4E and Q. So based on that, we are going to calculate the force. Clear? So we need to relate based on these two terms. Then only we can get that magnitude. So for that, we are going to calculate the force. Again, the same formula. So K plus 4E and E. The distance between these two is nothing but A square. So here K, we are going to take 4E and Q. The distance is nothing but we are going to take X square. So we can take any one force. So we will cancel the K, 4E will cancel, remaining not possible. So we will do that only one term is nothing but E by A square is equal to Q by X square. So based on this, we need to calculate Q. So I'm going to solve here. Q is nothing but E x square by A square. So this is the formula. We know that x is equal to 2 by 3a. So substitute here. So q is equal to e by a square. Instead of x, we have to write 2 by 3a whole square. If you do this, e divided by a square, 4a square by 9. So all the term we have to make it a square. A square will cancel. So finally we can write 4e by 9. So the net value of q is nothing but already we have the term is nothing but negative sign. So we have to take minus 4 by 9 into e. So this is nothing but magnitude of q. I hope it's clear. I'm going to move ninth one. So ninth one, an oil drop of weight is given 3.2 into 10 power minus 13 Newton. So weight is given in terms of Newton. That means we have to consider as a force. The given electric field 10 power 15 Newton per coulomb. Find the charge of the on the oil drop. It is in equilibrium. So this is very simple. They are asking about charge. So we know that weight is nothing but mg only we know, but they given in terms of Newton. So weight is nothing but sum of force, nothing but it's a force. So we have to consider as a weight is nothing but force. So the given force is nothing but 3.2 into 10 power minus 13 Newton, and E is given 5 into 10 power 15 Newton per coulomb. They are asking about Q. So based on this relation we already know the formula is nothing but F is equal to Q into E. Now we can easily calculate Q is nothing but F by E. So F is nothing but 3.2 into 10 power minus 13 divided by 5 into 10 power 5. So we need to cancel this. If you do the cancel this, 6 terms are 30. So finally we will get 6.4 into 10 power minus 19 coulomb. So this is nothing but final answer. So now I am moving to question number, sorry, model number 10. So model number 10, 2 point charges, one is 4 microcoulomb and 1 microcoulomb are separated by a distance of 2 meter in air. Find the point on the line joining charges which the net electric field of the system is 0. So these type of question definitely very important question. The same question, thus are not same question, same model of question will be discussed in chapter number 2 also. To calculate net electric potential of the system is 0. So all are in same model. So first one they given 4 microcoulomb, second one they given 1 microcoulomb, both are positive. They between the distance is nothing but 2 meter. So we are going to take that line of joining only. So this is the line of joining. So in this type of numerical we can solve three cases. One is left side of 4 microcoulomb we can take at a distance x, or right side of 1 microcoulomb we can take a point x, or we can take midpoint from here to x, that is 4 microcoulomb. So like this we can solve three cases. So we can take anything, but easy way, this also positive charge, this also positive charge. So definitely the equilibrium means definitely will be midpoint. So based on the previous question number 8. So now based on this we are going to take a point, the equilibrium point, we are going to take mid. Suppose this is a point we are taken at x. This is 4, this is 1. So this distance will be 2 minus x. So based on this we are going to calculate for equilibrium condition. For equilibrium we can take that E positive charge is equal to E positive charge. That means positive charge 1 is equal to second. Because at this point positive charge means the field will go like this due to 4. Then this is also positive charge. So this electric field will go this direction. So this point both are opposite direction. So we have to subtract. For that case only we q1 minus eq2 is equal to 0. So based on this only we are taken like this. So now we have to substitute E equal to, already we know, kq by r square. So based on this we are working. So q is nothing but 4 into 10 power minus 6. No need to substitute k value, directly we can go with k. So here is nothing but x distance x square, k into 1 into 10 power minus 6, distance is nothing but 2 minus x whole square. K will cancel, 10 power minus 6 will cancel, then we have 4 by x square is equal to 1 by 2 minus x whole square. We have to do cross multiplication. 4 into 2 minus x whole square is equal to x square. So we need to simplify this. For that you need to take square root. Take this, 2 into 2 minus x is equal to x. So multiply with 2. So 4 minus 2x is equal to x. So 4 is equal to 3x. So based on this, x is nothing but 3 by 4. So x is nothing but 4 by 3 meter. So at 4 by 3 meter it will get equilibrium from positive 4 microcoulomb. We have to conclude that from at a distance x equal to 4 by 3 meter from plus 4 microcoulomb, the system will be equilibrium. Like this we have to conclude the solution. So now I am moving to model number 11. Okay. So diagram is not given here, so I will insert the diagram. Model number 11. A hollow cylindrical box of length 1 meter. That means the mentioned the length also is nothing but 1 meter. Of cross-sectional area is nothing but 25 centimeters square. So the given length 1 meter, that is nothing but this length is 1 meter and this cross-section is nothing but 25 centimeters square. Placed in a three-dimensional coordinate system, so the given x-axis, y-axis, z-axis. The question is the electric field in the region is given 50 xi. So the given electric field is coming towards this x-axis. So like this is coming, but E is in. Actually, we have to take this is nothing but Newton per coulomb and x in meters. Find the net flux through the cylinder, then charge enclosed by the cylinder. So we have to calculate that net flux. Okay, first we will calculate the flux formula. Solution. First one. You know that flux is we can calculate in two way. So E into del S, or we can take Q by epsilon naught. Here we can't calculate flux through this formula, so we can use only this one. So this is not possible. Okay. So first we need to calculate that net flux they are asking. So net flux based on the cylindrical part we can take three area. So this is maybe first area, then surface we can take second area, then this will be third area. So now we need to find that del S. For example, if we take area 1, that we will take right side. So this is the closed surface. That means it's coming like this. So we need to draw area vector. So based on this surface, you have to take area vector 90 degree. So along this electric field is coming this direction. So based on this, theta is nothing but 0 degree. First case we calculated. So now we need to go for the second case. So we can take any surface like this. So it is a closed surface. So based on surface. Based on the surface, we need to draw a area vector. So this is a surface means I can take like this. This is nothing but area vector. Direction of electric field is like this. Between these two is nothing but theta is 90 degree. So we know that cos 90 will be 0. So now I am moving to left hand side. So this is the surface. This is the closed surface. So based on this, we need to draw area vector. So this is maybe area vector. So electric field is moving this direction based on the coordinate system. So theta is nothing but 180 degree. So we can calculate directly net flux is nothing but flux on right side plus flux on left side. No need to calculate the surface because we can write no problem. So surface. So we can write based on the formula E is given. Okay, first we will write EDS dot cos right is nothing but 0 degree plus E dot ds is equal to into cos 180, then E dot ds into cos 90. So now we need to directly calculate. So based on the diagram only we have to observe. It is very important one. So E value is nothing but 50 into x and area we need to calculate. The area already is given 25 centimeter square. We need to convert into meter. Okay, so we know that 1 centimeter is equal, sorry, 100 centimeter is equal to 1 meter. So we need centimeter square. For that I am going to take whole square. Then 10,000 centimeter square is equal to 1 meter square. Then 1 centimeter is nothing but 1 divided by 10,000 meter square, which is equal to 10 power minus 4 meter square. Clear? So now we have to write here. For area is nothing but 10 power minus 4 into 25. Clear? So we know that cos 0 is nothing but 1. Then plus. Again we have to write for E 50x into the ds is nothing but again 25 into 10 power minus 4 cos 180 is nothing but minus 1. So this term is 0. Okay. So given x is in terms of meter dimension. So x we need to calculate. This is 1 meter and this is length is also 1 meter. For right side this is right, this is left. So we are calculating here. So here right x is nothing but 1 meter plus 1 meter 2 meter. So 50 into 2 into 25 into 10 power minus 4 plus for left hand side the kept distance is 1. So 50 into 1 into 25 into 10 power minus 4 into minus 1. So this is your substitution values. So now we have to just multiply. So we can write 50 into 100, 100 into 25, 2000, 500 into 10 power minus 4. This minus we will take here. So 50 into 1, 50. So 50 into 25. So 25 into 5, 1250 into 10 power minus 4. So if you do this, you will get 1250 into 10 power minus 4. So coulomb per second. We need to take flux now. E dot del S. So E is nothing but Newton per coulomb, area is nothing but meter square. So 1250 10 power minus 4 Newton per coulomb meter square. This is your net flux. So second question, charge enclosed by the cylinder. So now we can use that Gauss law. So we calculate the flux. So the easy one. Same thing we have in exercise question, example question also. We know that flux is nothing but Q by epsilon naught. So Q is nothing but flux into epsilon naught. So already we calculate that flux 1250 into 10 power minus 4. We know that epsilon naught value. So 8.854. So while substituting this 8.854, you need to read that instruction page in your question paper. Sometimes they will give 8.8 into 10 power minus 12. Sometimes they will give 8.85 into 10 power minus 12. Sometimes they will give 8.854 into 10 power minus 12. So based on the instruction page, we have to focus. Then only we will get exact answer. So if you multiply this, our final answer must be like 1.1067 into 10 power minus 12 coulomb. So unit is always very important one. So now I am moving to concept number 12. So we'll read the question. So two parallel metallic plates P1 and P2 carrying a surface charge density sigma 1 and sigma 2. They mentioned sigma 1 is higher and sigma 2 is lower. So respectively placed at a distance d apart in vacuum. So determine the work done by the electric field in moving a point charge from plate 1 to plate 2 along the line of length L is lesser than D, making an angle by 4 with normal to the plate. They are asking about work. Clear? So work they are asking. So we'll go for solution. So work means is nothing but that F into displacement. Based on this we can write F into ds into cos theta. So first we got theta is given based on the given information 5 by 4 is nothing but 180 by 4. Okay, so we can do this 180 by 4. If we do this 4 5, that means theta is 45, that is cos 45. Okay, we get. So now we need to calculate ds, we need to calculate force, we need to calculate. Okay, so ds is nothing but we can take it as a length. So force we need to calculate. So force, we can't use this formula as per the Coulomb's law. This one we can't use because we don't know charge. So apart from, we have one more formula related with electric field, because between the parallel plates we can easily calculate. So F is nothing but Q into E. So based on this we can easily work out. So now we will do that. So this is nothing but plate 1 based on the concept. This is another plate. They kept at distance D. Okay. So we have in between a point charge here is there. So this is nothing but force direction will be there because this is Q1, sigma 1 and sigma 2. So we need to move a charge from one point to another point with an angle of 45 degree. So is nothing but 5 by 4. For this we need to calculate work. So we know that force is nothing but Q into E, but we need to calculate what is E. So we will study that concept based on the surface charge density. Suppose if we take midpoint here, so this is a positive only, this is also positive only. The direction of field will be this direction E1, this direction is nothing but E2. So net field between plate is nothing but we already know sigma 1 by epsilon naught minus sigma 2 by epsilon naught. Based on this, if we work, we can easily get. So E is nothing but 1 by epsilon naught sigma 1 and sigma 2. So now we can do that. Force is nothing but just we need to multiply by Q. So Q by epsilon naught sigma 1 minus sigma 2. So we calculate the force. Based on this, directly we can work with to find the work. So force into distance or displacement into cos theta. Force we got Q by epsilon naught. Distance they mentioned clearly, the line of length is nothing but L. So this is the distance, we can take L into cos 45. So cos 45 1 by root 2. So finally we can write Q by epsilon naught. I forgot to put sigma 1 minus sigma 2. Sigma 1 minus sigma 2 into 1 by root 2. So therefore work is nothing but QL divided by root 2 epsilon naught sigma 1 minus sigma 2 2. So that's all about work done to move a charge at angle 5 by 4. So now we are moving to model number 13 based on the pentagon. So given like 5 charges Q are placed at the corners of regular pentagon of side A. So AQ B like this given, side also A is given. Question is, what will be the electric field at O if the charge from one of the corners say, so A is removed. So if any charges at the corner is removed, they are asking about what is the electric field. So all are positive charge. So imagine at point O, the direction of field will be this one based on A. The direction of B charge is like this. The direction of C is like this. Direction of D is like this. And the direction of E is like this. Actually, five forces acting as a symmetrically. Clear? So, our aim is to find what is that net electric field at O when charge A is removed. That is the question. Also, they given clearly about the distance is nothing but R. So, each distance R. We already studied about the symmetric property. So, based on that, we can easily work. So, first I am moving with the solution. So, this is the concept. Solution I am moving. The first one, we will write the net electric field at the center is 0 due to symmetric property. That's mean electric, all the charges electric field is same, acting at same angle in different direction. That is the one. So E net is nothing but 0 Newton per Coulomb. If A is removed, okay, if A is removed, so what will happen? That is the one they are asking. So if A is removed means what will do? So what will happen? Now that point there won't be any charge, correct? So only we will get remaining four charges only will be there. This means here plus q will be there, here plus q will be there, here plus q will be there, here also plus q will be there. So at all the point we have R, this also R, this also R, this also R. The direction of field will be like this will be like this will be like this will be like this. So all the four fields are acting in different directions. But due to this there is no charge is removed. So we have to focus what happened to this. So definitely if all are positive charge for pentagon, if you are coming like this, based on the induction method, the negative charge will be induced here. If it is a negative charge is induced, so the direction of field will be like this. Because it will be attractive force. So the electric field due to positive charge A, if we remove, we will get negative field that is towards point A. For that case, we need to take negative sign of electric field of A is nothing but minus kq divided by r square. Because we don't know q value, we don't know r value, so directly we can substitute here k cube by r square, just writing the formula. Only thing is we have to use the sign negative. So now we are coming here next one. What would be the electric field at O if the charge q is at A is replaced by 9 minus q? The same thing only we are coming here. Okay, so they are asking about if you are placed q, what is that? Replaced by charge q at A is replaced by minus q. They are asking. So now if you are replacing by minus q, so again we are coming here. So initially first A is removed, here plus Q here, here plus Q is there, here plus Q is there, here plus Q is there. Now they are taken minus Q. So for that we need to calculate that net electric field at O. So here the field will direction will be like this will be like this will be like this, and by negative charge it will go like this. So already we have that minus Q. Based on that, so now the positive charge is removed by negative charge. So if A charge is removed, already we have another negative charge. So finally we will have minus Q minus QQ will have. So finally we need to calculate the field. So EA is nothing but K, already we have minus thing, Q is nothing but minus 2Q divided by R square. So finally we will get 2KQ by R square. So this is it. Electric field at center due to A. Because all other remaining forces will cancel each other, so we won't get the field. So that point O, only the negative charge will go towards that. So for that reason only we have taken the negative sign. I hope it may helpful for your board exams numericals. So please subscribe our channel. So next we will discuss about chapter 2. Like this we have 17 models of question. We'll discuss further. Thank you all.